Are you facing around 5% productivity loss and as well facing energy loss in your belt operated production machines and utility machines? Let us go in depth. Make your routine belt changing exercise as profitable now. Most of your industries, from the MSME to the large scale process plants, use belt operated machines in your production and utility machines, but you seek the guidance from the machine OEM to replace the belts on the pulleys, and you repeatedly installed belts multiple times on the worn out pulleys for a decade on these machines. But please be aware that your machine is still running over a decade with oversized belts and over designed belts on the dished out pulleys and glittering pulleys. So unfortunately all these years you ensured that the belts must be over strong enough so that no slippage or damage or wear and tear happen in your belt system. To ensure there is no loss of RPM between your motor and machine, you also upgraded to flat belts and timing belts, but this resulted in higher power consumption only. So normally said the pulleys need replacement after 40,000 hours of run. On condition monitoring the same, you plan to replace the pulleys and routinely after that years of run. Bureau of Energy Efficiency guidelines about the belt transmission between the motor and the machine. The motor drive transmission efficiency and the visible losses happening in the belts from the motor to machines. The efficiency of the mechanical power transmission depends on the grip of the pulley and the belt, and further depends upon the coefficient of friction and the strength or the tensile strength of the belt. And BE always said you can go for cogged belts instead of V belts. They have suggested the industries to go for replacing the V belts to the cogged belts, but because BE has told that every industry replaced the belts, but they did not replace their pulleys. You can see the losses in the V belts. The pulleys with V belts has caused so much losses in the machines, but they have replaced only the V belts to the cogged belts. That is not enough here. You can see for a 2 HP motor it is almost 8 to 15%, and for a 10 HP motor it is almost 4 to 8% the transmission losses. It ultimately results in the energy losses, and for even up to the 100 HP machine you can see around 2 to 4.5% it is happening in all your V belts. So the advantages of revisiting your daily running V belt driven systems and replacing the same to the space saver or a cogged belt conversion, what are all the benefits and how to go about this on this exercise. One is the power savings, next is the productivity improvement from that machine, then the heat reduction on this motor and machine, and the intermediate pulley transmission belts and pulleys, vibration reduction here, and the maintenance cost reduction, noise reduction because of normal tensioning, optimum tensioning of belts and pulleys, inventory cost reduction and profit improvement from that machine, and better utility of the motor, that is the motor is utilized optimally, either the belt is not over tensioned or the belt is not under tensioned, and the motor is tensioned optimally, and the better utility of the machine. The constant torque loads, the torque versus the power graph, thanks to the Bureau of Energy Efficiency, the guidelines given through the refresher guidebooks to the energy managers and auditors. And you can see any type of machine you can classify as constant torque load or a variable torque load or a constant power load, and most of the production machines are all constant torque load category only. And we are very much aware the motor power in kilowatt is the multiplication of torque and speed only with a constant factor. So in the constant torque loads, the torque is not a function of speed. As the speed changes, the torque remains the constant and the power changes linearly with the speed. This is what we have to take it up further in any of your production machines, and we have to keep in mind the torque as well as the speed when you are increasing the productivity of the machine or when you are increasing the RPM of the machine. I am just going to the case studies from different segments and different type of constant torque loads. Here it is a sand mixer in a foundry unit, and I should appreciate this management They just had a 250 kg sand mixer capacity, and they could run it only up to 70% of capacity, say at 180 kgs. They were planning to replace the machine and it is costing many lakhs, but the management wisely decided, let us try to improve the internals of the machine, and they just changed the bells and pulleys, and from 4 bells to 3 bells, and going for a normal V bells to the wedge type cogged bells. So, they could increase their productivity or restore their productivity 215 kg, almost 20% the productivity is restored by just spending just 10,000 rupees only. And since years it is running fine, only ELD wise replacement of the belt, and the machine is doing really well to the rated capacity here. So, the options you have in the V belt application is, first to look for the RPM slippage in your existing system, in your machines, with reference to the motor RPM, with reference to the machine RPM, and the speed ratio of the existing pulleys, and the RPM calculated and actual what is measured at both the ends, at motor and the machine. You have two types of the belts, one is classical, other one is a wedged and wedged cogged type variety. You can see the classical versions, they are the wedged cogged belts are replacing the classical belts now in many of the industries now. That is what we are going to elaborate further. The classical belt sections like A, B, C, D, E, and classical belt sections AX, BX and CX are getting replaced with wedged belts SPZ, SPA, SPB and SPC, and wedged cogged belts like XPZ, XPA, XPC, etc. And almost around 18 plus of varieties are there in belts, and you have to choose the right selection of the belts in discussion with your OEM, machine OEM, and with the belt and pulley expert who is the service provider for you to your industry. Coming to another case study, this is on the food processing segment. You can see here it is a pulverizer. Again, this is a constant torque load, and by going for the replacement of belts and pulleys from the old type V belts, which was running around in 4 grooves, and it is replaced with the cogged belts in 3 grooves, the energy saving and the productivity is achieved here. And this Vikram pulverizer, this OEM, they have standardized now in all their machines, say around hundreds of machines, they have standardized to these cogged belts, wedged cogged belts, and they could see their kWh energy saving around 5%, and the production also increased per machine to 10%. You can see from 580 kgs to 640 kgs per hour the productivity has increased in the pulverizing machine. So, the benefits of the cogged wedge belts and pulleys over the V belts and pulleys, we need to just revisit to this superiority of the wedged cogged belts here. The cogged belts have around 30% more power carrying capacity than the classical V belt size. Cogged belts run cooler and run for 50% more longer hours and occupy less space in the pulley. Narrow and cogged belts operate higher speed ratios using smaller diameter pulleys. Existing pulley to be replaced with around 20% less dimensioned pulley for the cogged belts. The cogged belt being cogged on the pulley side, the belt has a better grip with the pulley and ensures a steady RPM slippage, let us say around 1% over an year till the belt life. The better grip and higher coefficient of friction reduces the slippage to near negligible, around 1%, less than 1%. Cogs on the inner surface of the belt increase the airflow and facilitate the cool running of the belt. The flexibility due to the molded cogs allows the smaller sized pulleys to save the initial cost of the pulley cost. Ultimately, as a user, as a consumer, you from the industry, you need to buy the belts and pulleys from one source only. This is mandatory to improve the reliability and the grip of your motor and machine built intermediate power transmission. Coming to another case study of a rice mill cluster, you can see thousands of rice mills are running in each cluster. This are done on a polishing machine and the energy savings is achieved around 16%. Thanks to the implementation by our engineer Mr. Kandavel of Textile Engineers Chennai. And you can see on a 40 HP machine, the number of bells from 6 numbers have come down to 3 numbers, and the pulley, that is the bells, have been changed from classical size to space saver size belts. It is smaller in size and it is gripping more on the pulleys, and you can see the energy savings achieved is 16.5%. This need to deploy in many of the rice mill sectors, especially on this polishing and other machines, big machines that are there in each and every rice mill here. Coming to the textile mill, see, I am talking about the textile mill more because textile spinning mills are thousands of mills are there throughout India, and this ring frame application, it is a constant torque application, and 50% of the mill consumption goes towards the ring frame. I am just giving a different types of ring frame energy efficient conversion of these belts and pulleys. You can see it is a Pallava Textile, it is a big group based in south of India, and on this latest machine LRJ9 AXL, from the timing belt they changed over to the cogged belt and they achieved around 3% power savings. The energy savings achieved is around 3%. And from in another textile mill, the same ring frame, previously they were using, decades back they were using variator type version to change the speed of the spindle from 0 DAF to full DAF, and this variator has been replaced with the energy efficient cogged belt, and the UKG savings is around 6% and the production improved is around 3%. You can see the before and after conversion, the images, the production improved from 49.5 to 51.2 and the UKG 1.37 has dropped to 1.27. So, the case study explains on in the table how the savings is achieved. Next comes the LRJ9 SX, the image of the before and after with timing belt and with the wedged cogged belt. So, the another case study of a ring frame in the textile mill where LR9 bar X SX, from the timing belt to cogged belt conversion is done, and so around 7.4% energy savings is achieved by this Premier Tex products at South India at Srivilliputtur. And you can see they have done an excellent work and they have done the DAF study and they could see the savings, almost steady savings of energy savings of around 7%, and they have deployed this conversion, energy efficient conversion in all the ring frames. Coming to another textile mill where the ring frame LR6 bar S at RSWM Rajasthan, almost 9% kWh energy savings is achieved in this mill group from the flat belt to cogged belt conversion implemented by the Veterinary Energy Management Services, the unit of veterinary engineers by Mr. Jayaprakash of Veterinary Engineers Coimbatore, and the units per day before and after you can see from 650 units it has dropped to 590 units, almost 9% energy savings is been achieved, and the RSWM they are planning to deploy this energy efficient belt and pulley conversion exercise in all their ring frame machines gradually, and they have given this as a letter to say how much of 60 units per day they have achieved. That is what they wanted to convey here after the feedback after this exercise. Another textile mill where LR6X ring frame flat belt to cogged belt has been changed, around 3.2% the UKG savings has been achieved, and there is a scope for higher spindle speed as well. Around, let us say if it is running at 19,000 RPM, around 20,000, around 1000 RPM they can still raise for the same power, and at a comfortable running of the UKG and the machine ring frame they can achieve more as well. So, here the energy saving achieved is around 3%. So, all these hundreds of energy saving case studies has been discussed well in this book, Conserve Energy and Restore Productivity in Machines by the Belts and Pulley Drives. This explains all the detailed explanation is given in each and every case study. So, ultimately you have to ensure the belt is rightly sitting on the groove. This is what how it is wrongly done before and how it is corrected in the left side of the image, you can see it. So, to buy the books online, the Notion Press is the publisher and they have this book available online, and for all the energy management books it is available on this Notion Press as well. The main point which we wanted to suggest here and The energy saving conversion exercises has been designed and implemented by Mr. Engineer K.S. Subramaniam. He is a belt and pulley drives expert and from Mangal Singh Brothers, Coimbatore. The main point which we wanted to suggest here is, whatever you are trying to buy the belts repeatedly for your industry, you buy the belts and pulleys at one source where the belt dealer needs to be knowledgeable to give the right size of the belts and the corresponding pulleys, and it needs to be replaced once in 5 years only, but the belts and pulley has to be a complementary pair. It has to be rightly matched and it should be precisely matched in such a way that the torque is maintained and the tension is maintained, and you are getting a grip of the belts on the pulleys, and you are getting the energy savings as well. Thank you. Thanks for giving this opportunity. Thank you. Thank you.